This is problem 294. This is the one with the flagpole, and so A is actually on the flagpole, but they've given us FB and FC, and then they gave us stuff about the geometry. I really recommend looking at the actual figure in the textbook, maybe over mine, but it's also good for you to practice actually drawing out these things. So they want us to figure out, they want us to find this, this R, so this is the resultant force of FB plus FC. So to do that, let's get a different color, we'll have to figure out what the position vector is, right? Or what the two position vectors are. So we know the magnitudes of FB and FC, and we also know the direction of them because they tell us, we know what they start at A, which is at that 6 meters up on the z-axis, and then we know that B points towards that point B, that FB, and then FC points towards that point C. So here's that point C, and here's that point B, and here's point A. So we know stuff about the direction of it. So let's see. So FB is going to equal that magnitude, so that's 700 newtons, and then times, and then we need to multiply it times that position vector. And so remember, for these position vectors, what we want to think about is like, how do we get, so imagine that we're hanging out on point A, we want to get down to point B, so how do we get there? The first step is how far do we move in the x direction to get there? So if you look here, to move we need to move 2 meters in the positive x direction to get to that point B, right? So that would be 2 meters in the I direction. So that gets us lined up there. And then we also need to go over 3 meters in the j direction. And it's actually in the negative j direction because it goes away from the positive y. So positive y is right here. So we're going to go back 3 meters. So minus 3 times the j. And then we also need to go down 6 meters, right, in the z-axis. So we need to go down 6. So minus 6k. And those are all in meters. And you want to check that, make sure they don't sort of mess with you there. So that gives us FB. I forgot something. So that tells us the sort of how to get from one to the other, but then it needs to be a unit vector, right? So we need to divide that by the length of that. So divide it by the square root of 2 squared plus 3 squared plus 6 squared. And I guess I did the thing that I don't like y'all to do, where I didn't actually write out the formula that I'm doing. So for this formula, we have FB equals that magnitude of FB times that unit vector B. So I'm interested in that direction, that UB. The unit vector of B is going to equal that position vector from A to B divided by the length of that position vector from A to B. I'm sort of on top of myself here. Let's see. I'm going to just move this down a little bit. So that was basically what we did there. It's always better to write down the formulas, although I know it wasn't a good example for you. So then we can do the same for FC. So FC equals that magnitude of FC times that unit vector C. And that unit vector of C is going to equal the position vector from A to C divided by that magnitude of that position vector from A to C. So FC, and you could write out the unit vector and then put them together. I'm just doing it all in one step here. So FC is going to equal that magnitude of FC, which is what was given to us, that 560 newtons. And then we're going to do that position vector from A to C. So we're starting at A. How far do we need to go in the x direction to get to C? So if you see, we're starting at A, and this is just if we go down into the k direction. So we need to go 3 meters in the positive x direction, so 3I. We also need to go 2 meters, so that would get us to right here, basically. Then we need to go 2 meters in the y direction, so plus 2j. And then what we had already done was we already went down the 6 meters in the k direction, so minus 6k. And then we want to divide that by, see, this is divided by meters. See, this one's meters, and then we want to divide that by that length of that, so the square root of, of 3 squared plus 2 squared plus 6 squared. And that's going to also give us meters. And so it's good to do this where you actually write down the units. So meters divided by meters, so we'll end up with newtons, which is what we want for a force. We wouldn't want to have a force be in newtons times meters. So that gives us FC. Oh, we'll need to write it out. Thanks, I didn't write it out before. It's been a long day. Sorry, guys. But yeah, we'll go ahead and write this one out then. So 560 newtons. I'm gonna erase this because it got a little confusing. So we have FC is 560 times, and I'm just gonna go ahead and figure out what that denominator is. So 3 squared is 9. So 9 plus 2 squared is 4. Plus 6 squared is 36. The square root, so that gives us 7. So that'll basically be 3 over 7I plus 2 over 7J minus 6 over 7K. And that's going to be in newtons. So I'm going to move, I'm actually going to move a large part of this over to the next page. Copy. Paste. There we go. Let's see. Some of that got turned off. So I'm just going to erase all of this stuff. I didn't want the whole thing. So we're sometimes having a digital. It digitally makes it a little bit easier. So I'm just going to move this up. Or actually, I'll keep this down here. So this is FC. So FC, I noticed I didn't have the hat on it. We have the hat on it, that means it's a vector, so that's telling us direction and magnitude. So remember vector from the Despicable Me. So 560 times 3 divided by 7, that equals 240I. Let's see. So plus 160J, and then minus 480K. And that's going to be in newtons. And then we'll also do for the FB, which we sort of skipped earlier. So the bottom, or the denominator, see, it's 2 squared plus 3 squared plus 6 squared. So it's actually the same denominator as the earlier one, but you could calculate it also. FB equals 700 newtons times 2 over 7I minus 3 over 7J minus 6 over 7K. And then we have, so 700 divided by 7 would just be 100. So that's going to equal 200I minus 300J minus 600K. And that's in newtons. So what was the question? They wanted us to know the magnitude and coordinate direction angles of R. So we know R is going to equal, let's see. Yeah, R is just going to equal FB plus FC. Let's do this one. So R equals FB plus FC. So R is going to equal, so we have FB, which would be that 200i plus 240i, so that's 440i. And then minus 300 plus 160, that'd be minus 140j. And then minus 600 at minus 480, so that'd be minus 1080k. That's in newtons. So we know what the resultant force is. Now we need to figure out, because they wanted it magnitude and coordinate direction angles. So the magnitude is just the square root of each of those terms squared. Can't do that one in my head. So I'm just using my calculator. So I get the magnitude is equal to 1175 newtons, that resultant force. And then we need to figure out those coordinate direction angles. So to figure that out, we know that AX equals A times cosine of alpha. So let's see, I'm just going to write out the equation. So let's see, So A equals A, the magnitude of A times cosine of alpha I plus cosine of beta j plus cosine of gamma k. We know that, so we're interested in that R. So we know what each component looks like and what the magnitude is. So that this would be just A over that magnitude of A equals cosine alpha I plus cosine beta j plus cosine gamma k. So we can do this with our R. So R is basically that 440 I, and we can just divide each component by that magnitude, divided by 1175, minus 140 j over that 1175, minus 1080 k over that 1175, and that's going to equal cosine alpha I plus cosine beta j plus cosine gamma k. I'm just going to pull this over to the next page. So we've got that. So now we can figure out, we just take out those I terms. So I'm going to do I. So 440 over 1175 equals cosine alpha. So alpha equals just that 440 divided by 1175. 68 degrees, and then we have negative 140 over 1175 equals cosine beta, so that's this one here, that's what this one is. Just trying to color code them for you. So that gives us beta equals don't forget that negative sign, 96.8 degrees. And then the last one is this, which is basically negative 1080 divided by 1175 equals cosine of gamma. So gamma is going to equal 1080 divided by 1175 negative inverse cosine, 156.8 degrees. And that's this equation. So now we have our magnitude and all of our coordinate direction angles, so we're all done now.